Hello everyone. Today we are going to see how we can use Pegasus transformers for paraphrasing, right? So we are going to see 2 or 3 different type of outputs with the help of Pegasus. It can be sentence based, it can be paragraph based, and it can be a complete blog or topic based as well. So we are going to see a lot of different options in that, right? But the first thing is we need to see what Pegasus is, right? And for that I have opened that search paper for Pegasus for you. So let me show you that. So this is the paper for Pegasus. As you can see, it was published in 2020, and it is a paper that was first presented for abstractive summarization, right? So when we are talking about abstractive summarization, we can have novel results and novel words as well, right? When we are talking about extractive summarization, in that way the model is actually trying to make the summarization or make the paraphrasing out of the text that is given to it, right? But for the case of abstractive summarization, what happens is our model actually predicts and makes new novel words as well, right? Okay, so other than that, Pegasus is just like other transformer, decoder and coder networks, right? So this is the base architecture, of course, of the transformer, and it is also a typical encoder decoder network, right? So Pegasus was developed as well as compared with a lot of other architectures such as T5, BART. These are the architectures that have a very big name when we are talking about large language models, right? And on the basis of ROG score, we have a comparison of these models with Pegasus, right? So now, without wasting any time, what we are going to do is we are going to learn how we can use this Pegasus model, right? So we are going to use the Hugging Face library, transformer library, for that. So let me first show you the architecture that we are going to use. So there we go. We are going to use this tuner 007 Pegasus paraphrase, right? Which is already fine-tuned once again for paraphrasing as well, right? So we are going to use this model and we are going to implement it, and without wasting any time, let's see how we can do that, right? So we have opened a new Jupyter notebook, right? And we are going to do all of our work in this, right? So first things first, what is the first library that we are going to use? We are going to use transformer libraries. So if you do not have transformer installed, just write !pip install transformers and it will start downloading that, right? And I already have that, so I'll just delete it. So the first 2 things that we need out of transformer are the tokenizer as well as the model, right? So to get the model out, what we are going to do is we are going to import 2 things from transformers, right? So the first thing is from transformers import. Actually, this is a large language model. We need 2 things. So first will be auto tokenizer, right? And with a big T, and the second thing will be auto model. So we can actually use the Pegasus tokenizer model as well, but what I am going to do is I am going to use auto model for sequence LMs, right? So for that I am going to write auto model for sequence to sequence LM, right? So let's run this and let's move forward. So we have imported both auto tokenizer as well as auto model for sequence to sequence LM, right? So what is the next step? The next step is actually to import this model, right? So if we click on using from this, we can just copy both of these things. It will bring us the tokenizer as well as the model. So let's do that. Let's copy that here and let's run this. Now it's going to take a little bit of time to bring in the tokenizer as well as the model, right? So let's actually go forward. In the meantime, what we are going to do after that is we are going to import the pipeline from transformers, right? So from transformers import pipeline, and after doing that, what is the next step? The next step is to actually use the pipeline for Pegasus, right? So let me write that. The function I'll make is called NLP, right? So NLP is equal to pipeline. I'm going to use that here, and I'm going to use the tokenizer and the model that we have imported, and tell it we are going to use it for the case of text to text generation, right? So for that, I'm going to write text to text generation, and after that I'm going to give it two more things, actually three, right? So the first one can be model or tokenizer, anything we want. So model is equal to model, comma, tokenizer is equal to tokenizer. Now there is one more thing that I want you to add right here, and that is we want to make sure that truncation is equal to true, right? So why are we doing that? We are doing that because we can have big sequences for the case of paraphrasing or summarization, right? So that's why we are going to do truncation is equal to true, so that our tokens are united together, and we are able to process more data than the limit that is being given by this Pegasus, right? So that's why we are using truncation is equal to true in this pipeline, right? So what is the next step? The next step is to actually give into this the context that we want to paraphrase, right? So for that, I'm going to go on Wikipedia, right? So let's open this one. So it is about Spider-Man. This is this. So let's bring in all of this data, and let's write context and make sure that the context is a paragraph, right? So to make it a paragraph, what we are going to do is we are going to enter exactly 6 parentheses, and under that we are going to enter this, right? So now this is a paragraph. So it's giving an error. Let's try this. There we go. So all of this is inside our context now, right? Now we can use this context to actually do paraphrasing, right? So we can do multiple type of paraphrasing here, right? So the first thing I'm going to show you is the most insignificant type, in which I'm not going to break it into any sentences or anything at all. So for that, we only have to write something like a result is equal to and NLP, and in this NLP I'm going to write context, right? So context is right here. So what it will do is it will take all of this context, and it will use this NLP pipeline to create the result. Now we'll have a paraphrasing here as well, and a summarization here as well, right? So we will get a 1 to 2 sentence result, right, outside of this Pegasus methodology. So let me show you. There we go. So this is the result that we are getting. Spider-Man first appeared in a comic book in Silver Age of comic books, right? So as you can see, this is not written anywhere, right? Silver Age of comic book and these things, right? So this is not let me show you from here. So this is not written anywhere. Right here it is written in the Silver Age of comic books, right? So it is picking up different type of words to make a sentence which it thinks is the best suited as a paraphrase summarization, right? So the issue here is, if we are talking about paraphrasing, then this cannot be the actual result, right? Because it is actually giving us the result of one paragraph into a simple sentence, right? So what we need right here is to actually have each sentence being paraphrased, right? So we can do that with the help of this as well, right? But for that we'll have to use some conventional libraries of NLP, and the one that I'm going to use is NLTK, and I'm going to divide these paragraphs into sentences. So let's start that. The first thing is we need to import the NLTK library. So let's write import NLTK, and after that what I'm going to do is I am going to tokenize this all of this context with the help of NLTK. So for that I'll have to import sentence tokenizer, right? And it is available is in nltk.tokenize. So I'm going to write from nltk.tokenize we should import sent underscore tokenize, right? So let's do that, and after that let's move on to breaking up this context into sentences, right? So for that what I'm going to write is I'm going to write sentences is equal to, and then I'm going to use this sent underscore tokenize. So for that I'm going to write nltk dot sent underscore tokenize, right? And here I'm going to call the context into this, right? So let's do that, right? So now we have the sentences in here, so let's copy it and let's paste it. So there we go. As you can see, it is already being splitted out into different sentences. Now let me take two arrays, right? So array 1 is going to be an empty array, and array 2 is also going to be an empty array, right? There are a lot of different methods to do what I'm doing, but I'm using the most easy to understand method, right? So I have taken two arrays, and what is the next step? The next step, I want to add all of these to this NLP function, right? And then save them one by one into array 1, right? Let's actually use one array as a start, just array 1, and we'll see if we are going to use the second array. Okay, so the first thing, we need to make a for loop, right? So for I in range, how many sentences do we have? We have this number of sentences, right? So it is equal to the length of sentences, right? So if we have 8 sentences, then it should be starting from 0 to 8, and so it depends upon the length of the sentences, right? So other than that, what is the next step? The next step is add these one by one into our array, right? So array is array 1, and I'm going to use the append function, right? So let's write append, and after that what I'm going to do is I'm going to call in the NLP function that is going to do the paraphrasing, and inside the NLP function I am going to call in the sentences array one by one, right? So sentences of I will be one thing. Let's actually check out if sentences of I is something or not, right? Of course we do not want to mess this up. So sentences of 0, for example, will give us this. Sentences of 1 will give us this, right? So each will have different. Let's see what is 7. So we have a 7 as well, and let's see if there is an 8. So there is not an 8, right? So this is what it is saying, right? So there is a 0 here and there is a 7 here, right? So that means that what was the length of sentences? So 8, right? So that means what we need to do is we need to get this loop unto -1, right? Length of sentences -1, so that if there are 8 sentences, we are going to pick up 7, right? So one by one we are going to use NLP, and we are going to append the results into this, right? Now let's try this and let's see what do we get, right? So it is going to take some time, and after that what we are going to do is we are going to output array 1 to see what the results are. So let's wait. So now let's see what is array 1. So this is the generated text. This is the paraphrase text for the first sentence. This is the paraphrase text for the second, third, fourth, fifth, sixth, until the 8th sentence, right? So this is how we can paraphrase with the help of tuner 007 paraphraser, right? And after that we can just use the join command to join all of them to make it a paragraph again, right? So let's do that now. So let's write array 1 actually it will be array2, right? So let me first bring in this, right? Actually let's write for I in range, because we want this part only, not the whole sentence, right? So we do not want this, we only want this, right? So for that we are going to save this into array2, right? So I'm going to write for I in range length of array1, so length of array1, right? And after that I'm going to write array2 dot append, right? And in this, what I'm going to append this with, I'm going to append this with array1. And let's focus on this for 1 second, right? So if we are seeing this, this is the array1, right? So let's took a deep look into this. So this is the 0th value, right? This is the first, then second, then third, and so on and so forth, right? So in the ith value, I will be 0 here, then 1 here, then 2, then 3, right? And all of that. So in the I value, what we need to have is, we need to have the 0th position, right? Because this one, this curly bracket, this dictionary is at 0th position, right? So for that we will write 0 here. So whenever we are in I, we want to go into the 0 location, and from the 0 location we want to pick out the generated text, right? So let's copy that and let's paste it here. So we will get this part out of that, right? If I'm not wrong, right? So let's run this and let's see what is array2. So there we go. This is array2. This, all of this has been deleted, and now we have a very clean text in which we are only getting the sentences out of it, right? So now the last part is to actually join all of those sentences. For that, let's just say para is equal to, we want to join them with the help of a space, right? So let's give in a space. So para is equal to space dot join, and in this I am going to write array2. So let's run this and let's see if this gives an error or not. So it's not giving an error. Today is a lucky day for us, right? So this is it. This is the complete paraphrased paragraph, and this was the complete unparaphrased paragraph, right? So if you want to take it a step further, you can just add it into a function and then give a paragraph into the function, and then you will get a paraphrased output out of the function as well, right? There is something else that we can do with that, right? So we can just create a very simple web app with the help of this, right? So I'll be doing that in the next video, right? So we'll be picking up web-based architecture. It can be Anvil, or it can be something like Streamlit or Bubble.io. I'll see what we cook up, right? But what I'll do is I'll take up this and put it into a function, right? And after putting that into a function, what will be the next step? The next step will be to make a web application, a very simple Python based web application with that, so that you can make other applications like this as well, right? So this video will be a two-parter, right? This is the first part, and the second part will be coming in the next week. So I hope you enjoyed this video. For other videos related to artificial intelligence, especially in NLP and computer vision, keep watching AI Studio. Thank you.